So I can use this 1 to reduce these entries to 0. In order to reduce this negative 1 to 0, I can simply add the first row to the second row. And in order to reduce this number to 0, what number do I need to multiply to the first row? Right, it's going to be the negative of this entry divided by this entry. So it's going to be 3 plus 1 multiplied to the first row. So I will get a 3 plus 1 to be added to this negative 3 minus 1. Adding that to the third row. So now I can use this 1 to reduce these entries to 0. I can reduce this negative 1 to 0 by adding the first row to the second row. So the first row remains the same. The second row now becomes 1 minus 1, that's 0. 1 minus I. 3 minus I minus 3, that's negative I. And to reduce this entry to 0, I need to multiply the first row by a number. And what number do I need to multiply? That's right, it should be negative of this entry divided by 1. So there should be 3 plus I multiplied to the first row and adding that to the third row. So this number becomes 3 plus I minus 3 minus I. So it's 0. This number becomes 3 plus I minus 2, so 1 plus I. This number is 3 plus I multiplying 3 minus I. That gives me 10. And minus 9, that's 1. So I've successfully made these numbers become 0. The next step would be, since this entry is not 0, using that to reduce this entry to 0. But now, just like in the previous steps, because this entry is complex, directly using that to reduce this entry to 0 will involve dividing the number by this complex number. And I'd like to avoid that because it's not necessary. I can take another step to make sure this number become a real number again, which will be much easier when I try to reduce both this number and later on this number to 0. So what I would do is to multiply the second row by the complex conjugate of this entry so that this entry becomes a real number. So I'm going to multiply the second row by 1 plus I so that this number is 1 squared plus 1 squared, 2. And this entry is negative I times 1 plus I, so that's 1 minus I. And now it's easy to figure out that I can multiply the second row again by 1/2 so that I have a leading one in this entry. And I can now use this entry to reduce this entry to 0 by multiplying the second row by negative 1 plus I and adding that to the third row. So this entry now becomes 0, and this entry is 1 minus parenthesis 1 plus I parenthesis times half of 1 minus I. And this entry you can calculate turns out to be 0 too, which makes sense because this coefficient matrix is singular. So we've reduced the augmented matrix to this matrix. And in order to further reduce it to reduced echelon form, we'll use this entry to reduce that entry to 0. So multiplying the second row by negative 1, adding that to the first row. The second and third rows are the same. The first row becomes 1, and this is 0. This is 3 minus I, subtracting this number. So it's 5/2 minus half of I. So the augmented matrix is now in reduced echelon form, and from there we can tell the general solution. From the first row, x sub 1 is equal to negative 5/2 minus half of I times x sub 3. And from the second row, x sub 2 is negative this scalar, 1 minus I over 2 times x sub 3. And x sub 3 is an independent variable. So writing the solutions in vector form, we know the solutions are all 3 by 1 vectors, x sub 1, x sub 2, x sub 3, that can be written as, according to this relationship, replacing x sub 1 with this expression, negative